Okay, so the last section of the notes is just kind of putting everything that we've learned in chapters 3 and 4 together. And so when we solve a triangle problem, we should always start with drawing the diagram, label everything you know. It might not be what you need to know, but if you label everything you know, you can probably find out some other information and go from there. So if you look at your triangle and you have a right triangle, go to your primary trig ratios right away. Go to SOHCAHTOA. It's the easiest thing to do. It's the most straightforward. Don't get tangled up in sine and cosine law if you have a right triangle. But if you have an acute triangle, so something that looks like that, or an obtuse triangle, something that looks like that, then you have to decide based on what you have in terms of sides and angles, and decide, do I want to use sine law or cosine law? And remember that when you're using sine law with an obtuse triangle, you have to determine, do I want an acute angle or an obtuse angle? Okay, and we'll go over that. We'll see an example of that. And we've seen an example like that in the notes. So if we look at example, we have a surveyor in a helicopter, and he wants to know the width of a lake. And this kind of thing is done quite often because there's lots of remote places in Canada. And so it's not feasible to send people down there on the ground, and sometimes it's not even possible depending on the weather, but you can survey it from helicopters. So I'm going to try to poorly draw a helicopter. Okay, so we have our helicopter, and we're going to assume that it's level to the ground, okay, that it's not dipping in any way, just for safety's sake for the helicopter people. And we know that from the top of the helicopter to the forest floor is 1,610 meters, and they tell us that right there. And we're looking for the width of a lake. So we'll say that's our lake, and so what we're looking for is this length down there. Okay, and so if we draw a triangle up to the helicopter, that's what we'll see there. And the other thing we're told is that the angles of depression to 2 points on the opposite shore of the lake measure 45 and 82 degrees. Okay, so when we talk about angles of depression, we'll look here. So to get over, so this angle of depression, so it would be if you have your person in here and they're looking down, this angle of depression is 45 degrees. And then you have this big angle of depression, the second one. So this person can be looking down to the far end or looking down to the nearer end of the lake. And so this one is 82 degrees. Okay, so then we'll label our triangle WXY, okay, because W has to be across from width. And we'll talk about what we have. So we have an obtuse triangle. So what can we find out from here? And then just look at it and see what you have. So I have these two angles here. I have 82 is this whole angle, and 45 is this angle. Just by using subtraction, I can find this angle here. So that's interior angle W equals 82 degrees minus 45 degrees. So then that's 37 degrees, right in there. And then if I look at my drawing, I've drawn these two lines here. Up here, this is the horizontal line, and then down here is the ground. And again, we're assuming that the helicopter is holding steady horizontally above the ground. And so then these look to me like parallel lines. And when I have parallel lines, so we have parallel lines that look like this. We'll just redraw it out here. Okay, and if you look here, it looks like we have this line that comes down and connects them. And we're given that this is 45 degrees. So if we have parallel lines, let's remember things we can find and things that we need. Down here is angle Y, and we know that that's 45 degrees. Because So can find angle y because alternate interior angles are equal. So, and then therefore angle y equals 45 degrees. And then if I look at my triangle to do with the lake, so there's my triangle there, y, w, and x. I know y and w, so I can find x. Angle x will equal 180 minus 37 minus 45. So angle x equals 98 degrees, which makes sense because we said that we have an obtuse triangle right here, and we need one angle over 90 degrees. And this is the sum of interior angles on a triangle, or in a triangle, equal 180. Okay, so now I look at it. I have all the angles in the triangle I'm working with, okay? So to find W here. But I have no sides, and that's a problem because I need at least one side to use sine or cosine law. But if you look at it, what do we have here? We have another triangle in this diagram using side y, and here the height. We have a right triangle. So I'm going to just draw that right triangle down here. So we have side y, and we had the height, and that equaled 1,610 meters. We have that angle here, and we can find this angle. Again, if we look up here, this is the exterior angle here, and so this will be 180 minus 98. So this angle will be 82 degrees. So I have this angle here. If I look out, I have opposite over hypotenuse. I'm going to use SOHCAHTOA, because this is a right triangle. Because I have opposite and hypotenuse, I'm going to use sine. So I start with sine 82 equals opposite, which is height, 1610 over y. Now to get y by itself, I multiply both sides by y. Now I have y sine 82 equals 1610. To get y by itself, I divide by sine 82. I'm just going to bring it up here to save space. So I'll get y equals 1625.8 meters. And I'm just going to keep that 0.8 for now just to be really accurate. So if I redraw the triangle that I am aiming for, again, my obtuse triangle. Sorry, that's a kind of terrible triangle. I know that that's 37, 45, 98. And now I know that this is 1625.8, and I'm looking for W. So now can I use a sine or a cosine law? Yes, I can. I have a side and an angle, and a side and an angle, and so I can use sine law. So this will be 6, use sine law to find W. So I have W over sine 37 equals 1625.8 over sine 45. So this was W over sine W equals Y over sine Y. And again, if I multiply both sides by sine 37 to get the W by itself, I get W equals 1383.7 meters, or W equals 1384 meters. So the width of the lake is 1,384 meters. And so again, when we started, we weren't given a ton of information, but using your knowledge of geometry and trigonometry, we can usually find everything we need. So let's look at example 2. So Leanne and Carrie are hiking in the mountains. Okay, so let's draw a picture based on what they're doing. So they started in the parking lot, and we'll put that here. So we'll put P for parking lot. And they hiked northwest for 12.4 kilometers. So again here, if I have north, east, southwest, northwest is 45 degrees that way. So they walked up there to C for campsite. Okay, and then they walked, and that was 12.4 kilometers. Then they turned south, so they went straight down for 7 kilometers. Okay, and they went to the lake, and I'll just make that a little bit shorter. And again, this won't be to scale. So they went to the L for the lake. But then a storm moved in, so they hiked back to the parking lot at an angle of 30 degrees. And we're looking for this length here. So this would be length C. So let's just take a second and look at what we have. Okay, and while directly north is 45 degrees, we are told here that from the parking lot to the campsite is 30 degrees. So we'll put in a 30 degrees here. And then let's look what we have. So we don't have tons of information. We have 2 sides and an angle. And with 2 sides and an angle, so I've got that and I've got that. So we can use W, sorry, angle L over equal 30 over 7. We get that sine L equals sine 30 times 12.4, because we multiplied both sides by 12.4, divided by 7. Sine, and then sine L equals 0.8857. So L equals sine inverse of 0.8857. So L will equal 63 degrees. What kind of triangle do we have? Anytime we're using sine law, I gotta think, what kind of triangle do we have? We have an obtuse triangle. L, it's greater than degrees, so angle L. So angle L is obtuse, but we got 63 degrees, which is not obtuse. So angle L equals 180 minus 63, because we need to find the supplementary angle. So angle L will be. So now I'll take out these little lines here. We know that this is 117 degrees. So now that we have those angles, and up here is C. Don't know why that won't draw. Okay, so up there, angle C. So we can find angle C using our rule that interior angles in a triangle sum to 180 degrees. So angle C equals 180 minus 117, which we just calculated, minus 30, which we were given. So angle 3 degrees. And go back up. Oh, it was filling in. And we have 33 degrees. And again, we're looking for C. So now we have 3 angles and 2 sides. And so again, we can use any of the laws. We can use sine or cosine. I'm going to use sine. There's just less steps in it. So we can find C using sine law. And if you want, try it with cosine law. You should get the same answer. So we have C over sine 33 equals 7 over sine 30. And again, you can use, if you want, you can use, I'm not sure what happened there. Okay, you can use 117 and 12.4. But again, it's always safest to use things you were given. We were given 7 kilometers and we were given 30 degrees. We were given 12.4 kilometers, but we calculated 117. So if you made a mistake on your calculation, like say you forgot about the obtuse rule and you used 63, then you'll get another wrong answer. But using the 7 and the 30 gives you a better chance. So we'll come over here. C equals 7 times sine 33 over sine 30. So C equals 7.6 kilometers. Okay, and let's do the last example together. Scott is a fish biologist studying lake in Lake LaBerge, Yukon. Scott makes the measurement shown in the diagram below. He determines that the length of the lake is 36 kilometers. Is he correct? Show your work. Okay, so these degrees were provided with using that, this angle here. And let's A, B, C, and identify this triangle. This is an acute triangle. And so angle A, just one second. Angle A, we'll just use our sum rule. Angle A equals 180 minus 52 minus 74. Angle A equals 54 degrees. So we'll put that 54 degrees. Okay, and we want to solve for B. So this is the length over here. Okay, so now Scott tells us that it's 36 kilometers, so we're going to verify if he's right. And we look at what we have, and we have an angle and a side, and an angle and a side. So again, I'm going to go to sine law. So we'll use sine law to solve for B, which is the length of the lake. Okay, so we'll go B over sine B, which is 74 degrees, equals the length that we're given, so A, which is 41 kilometers, over sine 54, which we just calculated from the sum of interior triangles. So we get that B equals 41 times sine 74 divided by sine 54. And then we end up with, if you do this in your calculator, B equals 48.7 kilometers. And I always recommend that you do all the calculations in your calculator to make sure that you're using your calculator correctly, and to just make sure that the math is correct and that you're understanding the process of doing this. So 48.7 kilometers. Now Scott, if you recall, said that the lake is 36 kilometers. So we'll forgive Scott because he's a fish biologist, not a mathematician, but he is wrong. So therefore, Scott is incorrect. Okay, and we're glad that Scott's not a surveyor. Okay, and then just a couple minutes on things for the test. So this wasn't a very long unit, and so each chapter is equally important. So I know that chapter 2 was review and we didn't spend a lot of time on it, but it's really, really important for you to be able to understand all those rules. So, you know, things like alternate exterior angles, if we go through, and then alternate, those are alternate interior angles, alternate exterior angles, things like vertical angles, supplementary angles, consecutive interior angles. All of those things will really, really help you. And if you look in your review package that I handed out in class and is also posted, you'll see that the first few pages are all geometry, okay? So calculating angles. And that's really, really important because then we bring that down into chapter 3 and 4 when we use trigonometry, because trigonometry is based off of geometry. And so what we basically went over a little bit SOHCAHTOA. And remember that you're going to be given that yellow sheet that we had for the quiz. So you don't have to memorize SOHCAHTOA or the sine law and cosine law, but just be really, really familiar with using them. So if you have a right angle triangle, go to SOHCAHTOA right away. It's the most basic, it's the quickest way. And just remember that opposite the 90-degree angle is always the hypotenuse. The adjacent and opposite depend on which angle you're in. So if you're in this angle or that angle, but your 90-degree angle is always opposite the hypotenuse, and the hypotenuse is the longest angle. And then for sine and cosine law, so you have A over sine A, B over sine B, and C over sine C. But remember, you only need 2 of these. You're never working with all 3, okay? And put what you need, so put what you don't know on the top. So if you're looking for a length, put the lengths on the top. But if you're looking for an angle, put the angle on the top. It's just a little algebra trick that makes your life a little bit easier in calculating. Okay, and then with cosine law, so remember that we have, if we do a squared equals b squared plus c squared minus 2bc cos a. Okay, so you're going to either be looking for an angle or a side. Put whatever your unknown is here and here. So if you're looking for, say, angle B, start with the b squared version. Cos B. Okay. If you're looking for side C, put it over here. Okay. A, B, cos C. Okay, now with acute triangles, you can just use sine and cosine law. Whatever angle you get or side you get, that's fine. With obtuse triangles, be careful with sine law, okay, because remember that sine will always, always, always give you the acute angle. But if you're working with an obtuse triangle and sine law, so this is obtuse, sine will always give you acute, so you have to find the supplementary angle. So if you calculate, and this is, let's say this is angle A, you say, oh, angle A with sine law is 50 degrees. But you look at your triangle and you know it's obtuse, and this is why every time you look at a triangle, identify it as obtuse, right, or acute. And it'll just make it much easier when you go forward. So therefore, angle A equals 180 minus 50 to find the supplementary angle. So it'll be 130 degrees. Now again, work through the review package. If you can do the review package, the test is quite similar, so you should be good to go for the test. I will be posting the bonus quiz up when I get home this afternoon, along with your latest version of marks. So go through and see if anything's NHI and bring it in on Tuesday. The bonus quiz will be pulled down Saturday morning, so make sure you get it before then. And remember, if you're going to want to make corrections, that day will be April 18th, so that's next Thursday at 9:30 a.m. And you'll need to bring your completed review package. So having it done before the test will not only help you study, but it will be good because then you're prepped for corrections. So please email me if you have any questions. Come in Monday if you have any questions, or Tuesday morning before class. This test is a little bit shorter than the last one. But again, be very familiar with your geometry, with all your parallel line rules. and be able to use SOHCAHTOA, sine law, and cosine law. And to use those, you have to identify what kind of triangle you have. Have a good weekend, and again, email me if you have any questions.